Please welcome Christoph, the CTO of Necture, Markus, Head of Unit Digital Resilient Cities at AAIC, Julian Aberger, Chair of Waste Processing Technology and Waste Management recAIcle at Montanuniversität, Leoben. And one last time, he is back on stage, Clemens Wasner from AAIC, Austria, your host of this panel. Welcome, gentlemen. One last time, I have the great honor and pleasure to hand over to you, Clemens.
Thank you very much. Yeah, welcome back from the lunch session. I hope you enjoyed the lunch and you also had some coffee and don't fall asleep, because this is normally always a problem after lunch. So before we, let's say, dive into the question and discussion round, maybe if each of you could give a very brief statement, let's say like 1, 2, 3 sentences, what your organization is doing and what it's doing in the context of urban technologies. So let's start with the right-hand side.
So I'm working at the Montanuniversität Leoben, and we are working on digitalizing the waste management and waste industry, starting with waste logistics to waste sorting and end with waste treatment and recycling.
Yeah, hello. Thanks for having me. My name is Markus. I'm working for the Austrian Institute of Technology. So it's the largest non-universitarian research organization in Austria. So we cover a lot of topics. I'm heading the group of digital resilient cities, and so we're supporting cities and also project developers in the construction sector to make cities more sustainable.
Hello, my name is Christoph, Walcher, CTO at Necture. Necture is coming from an angle that the transition to a sustainable future is not fast enough. So we want to speed this up by making shared mobility a feasible option in multimodal public transportation scenarios. We want to use EV charging infrastructure more efficient, more optimized.
Excellent, thanks a lot. Yeah, when we, let's say, had the pre-discussion for this panel, one thing that was very obvious, that almost every person has a different definition of what urban technologies are. So the answer is all of them together are urban technologies. And the second one was when we now talk of utilizing the things your research institutions and companies are developing, who is typically the party that wants to implement this? Are these the cities themselves, or let's say with the different let's say departments within the city? Or is it rather private companies servicing the cities that knock at your door and say, hey, could we use your research results? Like, let's say, if you're in the garbage business or waste treatment, can we use your technology? So that would be interesting. Who, let's say, where's the pull coming from for your technologies?
So the pull for new technology mostly comes from in waste management from the government, or in our case from the EU, with all the recycling regulations, for example, recycling rates. And we have to fulfill that. And companies or waste management systems contract waste collection companies, waste treatment companies, waste sorting companies. And they agree upon that they fulfill this agreement. And in there, for example, they have to recycle at least 55% of plastics next year. And so that's the push. And then the pull comes, these companies are searching for solutions, how they can achieve these ambitious goals, and come to us and ask for technology and advice.
Okay. How is this on the AIT side?
Yeah, that's a combination. It's pull and push. So everybody's facing at the moment, okay, sustainability is getting more and more important. And so we have a high demand on requests how we can, for example, city support in the decarbonization of mobility, of energy, but also facing current impacts of climate change. So what can I do now against that changing weather conditions, for example, with nature-based solutions? But in general, our service offer is most times a combination between consulting, because it's very important. Also, if you use AI methods, that you have some domain knowledge to get the right results or the best interpretation out of that, together with expert tools we develop. So in some special cases, we also do modeling and also provide simulation software, but most times we go in a co-creation process with our customers, with different stakeholders to advise them together to find a common way, because everybody has different aims and goals, to get a good performance of the idea at the end.
Good. Last but not least, Necture.
Yes, thanks. The pool is coming for us from more or less 3 different market segments. First is car sharing provider, really providers that offer car sharing to their customers, because there are so huge demand and supply gaps and also pattern changes over time that it's needed to operate a car sharing provider efficiently, that some vehicles are repositioned depending on the current demand pattern. The second market segment is companies that want to inflate EVs in their business fleet. And the third market segment where we experience push and also some pull and also some push is needed there. This is CPOs, utilities that operate in the energy field.
Okay. Speaking of, let's say, the route optimization and so on, you mentioned a very interesting example when it comes to the, let's say, what your institute is working on. Maybe you can elaborate a little bit on the thinking behind the garbage collection trucks.
So a lot of garbage collection is done by lorries. And the routes are optimized by an AI, so that you don't pick up any waste bins that are empty, because it's you start, you park, you start again. Costs a lot of fuel. And with electric vehicles, you have the possibility to regenerate energy by braking. And so the routes are optimized to pick up only the full bins, and also that the lorry, when it's empty, is driving uphill, and when it gets full and fuller and heavier, means it needs more braking. So the route is constructed that when it's full, it goes downhill, regenerating energy, saving energy, and so we can optimize the route. The full route is possible with a relatively small battery, and also the battery is about a third full again when it reaches its destination.
Great, thank you. I don't actually know where the noise is coming from. I hope it's not coming from me. Time for audience participation. I mean, I'm pretty sure most of you in the audience are familiar that there are lots of AI strategies on a national level, like the United States, China, Japan. Almost every country nowadays has an AI strategy. But let's say, who of you is aware that, for example, Vienna has its own AI strategy, or cities like Amsterdam and so on? It would be interesting. Yes, relatively. It's below 50%, definitely. Because when we put together this panel and so on in the planning, one of the things that nowadays is evident in the AI field, that it's actually the cities that are in many times pulling ahead when it comes to developing a strategy, and also when it comes to the implementation for cost reasons, like the garbage sorting, what we had before, or let's say when it comes to transportation and so on. And yeah, with this rather long intro, I would play the ball to my friend from the AIT. What are emerging fields or emerging areas of interest that you nowadays witness in urban tech?
Speaking, for example, for urban planning, there is a huge interest how we can develop buildings and neighborhoods in a way that they are really sustainable, because there are a lot of investments today you need to take. At the end, you have a life cycle for at least 40 years. So decisions you now take are stable for this certain period. And so that is one thing where emerging is how can we take the right decisions. So each design options, if you think, for example, you have a neighborhood and you change minor things in design, you rotate, for example, a building that could have a huge impact on the local wind comfort, for example. So it could be better to rotate it a little bit in the other direction, or also what's about recreation zones and how can I set up that and how can it be fit against the climate impact today. So nature-based solutions, for example, when you're talking about rewilding or also talking about greening and planting some trees there. So there is an impact not only on the local climate, definitely, but also, for example, pedestrian footpaths. And the overall complexity of this system is so high that it's not easy to take decisions, also when having all the information, because you have different interests. And that is at the moment emerging demand to support cities, but also the construction industry in taking the right decisions at times where the investments or changes, cost of changes are very low.
Thank you. You want to add something? Because you just got the new microphone.
I just got a new microphone to test it. For us, change is coming. We talked about logistics. And logistics are quite digital at the moment. But waste sorting isn't the next step. And waste sorting is the most important step for recycling. Because if we don't have sorted material, we can't produce secondary raw material. And so we try really to implement digital methods and models into the sorting part and to help these companies to step forward in the right direction and to get more yield out of the waste stream that they can recycle.
A small follow-up question, because on the very first AAIC, that's really a coincidence, you know, there was this very famous example in the last decade from Google that worked with a Japanese cucumber farmer for the cucumber sorting. So we had the guy, Kazuhiro Sato, he was Google internally, he was called Mr. Cucumber. So he was talking how AI can be used in, let's say, in agriculture to improve the quality of the pre-sorting and so on. What I would be interested in, if you could provide us some, let's say, key facts, like which degree of sorting do you achieve? Like how much, by how many percentage points is an AI-based sorting better than, let's say, a regular approach? And for which types of garbage collection?
So these systems we use to sort automatically, they're mostly near-infrared based. So they see the spectra emitted by the material and can define the material category. But the systems are limited. With plastics, it works quite good, but only if the plastics are not black or don't have a lot of labeling or multi-layer, because a lot of plastics, like food packaging, has up to 13 layers of different plastics, and we only see the top one. And with AI, we see other things. We don't see a spectral data, we see the form, the producer. So we can sort differently. We sort more like human, and humans are the best sorting machines. So we get more out of the waste stream we have and can sort many different categories that are not possible with near-infrared or other sensors.
Thank you. And just for reference, how many cities are already, let's say, using the research results from University of Leoben?
I think a lot of companies have implemented some things because we could save them a lot of money. For example, also in plant operation optimization, because a lot of plants are built, dialed in, and run until they don't run anymore. And that's another big part we are trying to work on, how to get to a smart factory where we have dynamic control of all the different machinery in there, because waste changes. For example, waste in the summer, where a lot of people make barbecue, is not the same as the waste in the winter. So we have regional events that affect it, or it changes over time. But all the factories, sorting companies, all these plants are run statically. So we have a lot of potential to get some dynamics in there.
Great, thank you. When it comes to how a field is developing and, let's say, pivots, as it's called in the startup world, I mean, your company is no stranger to that, because the first time we had your company here on the stage, it was called ParkBob. So that comes from parking a car and finding a parking space. Then it became Ubic, ride sharing and so on, and now it's Necture. So could you elaborate a little bit like what is the driver, let's say, for this type of pivots, and especially what you told me just now before we entered the stage in terms of the charging infrastructure, how this is also directly affecting the communities and municipalities that they get interested in your product?
As long as I was working for Ubic, we were from a market segment very focused on car sharing providers. Along with EVs being inflated with car sharing providers and discovering that the charging is something quite complicated. If you compare this to the operational complexity of a combustion engine powered car, an EV imposes new qualities and complexity and effort for car sharing providers. So with offering charging services and so on, we discovered also that there are some crazy imbalances in the availability or usage of existing car charging infrastructure. So opening to a new market segment, CPOs and so on, made it was not really a pivoting this time, but a rebranding. It made it a need to be done.
And which regional differences do you see in your customer base? Because you started originally in Vienna, then I think it was with Amazon Alexa. The Amazon Alexa had the Parkpop skill. I think that was in 2019. So then you had, let's say, quite a large footprint in the United States. So where is nowadays most of the business happening, and how do you see the regional differences?
Don't remind me of that Alexa skill. It's a pain still. Regional differences. I see more in an openness of potential customers for technology, of also relying to a certain bit on AI that it will do the job. Right, that we can observe it and steer it a little bit. There I think is from a market perspective the highest regional difference.
Good. Coming to research and regional differences. So yeah, you're already looking at me. You know I will address the question to you. I mean, when it comes to urban tech, digital twins, whatsoever, Singapore is always mentioned as like the example, and everybody will follow Singapore. It's quite similar to what you have in startups and IT and Silicon Valley. It would be interesting to get now from somebody that is very deep, but also with a wide breadth in the topic. What do you think? How much of that is true that Singapore can be considered a lighthouse, and what of it is so specifically local that it's not really adaptable for the rest of the world?
Ooh, hard question. In general, yeah, I think there are many lighthouse activities, and often lighthouse activities like Singapore there's a huge funding behind, and there is a strong interest, and you have a lot of resources to tackle some challenges. And I think that is maybe also a little bit different in different countries, Europe against USA, for example. But in general, I think everybody, or there are a lot of competences also in national things. We have very good inventors, to be honest. Also, EIT tries to support new ideas and try to bring them on the market together with good and willing people, let's say, because it's some different step coming from technology development and go to economy at least. But in fact, it's good to have some lighthouse projects. Like it's not only Singapore. There is some activities in MIT. There is also in Germany a lot, but also here a lot of little bit smaller activities at the AIT. For example, we also have an AI task force at the moment. It's a new implementation. So over the whole group of AIT, because we have a lot of competencies, expertise in single units or research fields, and the hard work is really to combine that competencies and bring out some value out of them.
Thank you. Because unfortunately, you want to add something? Because you did this.
But I can also give a good example for a startup. So it's also a good example how AI can help in evaluating urban designs. For example, we started 2017 with a PhD program called Codec. It's not worth to mention that now, but the idea was to use computational performance and computational methods to make cities more sustainable. And one finding there was, and that was very interesting, one major request always is how to calculate wind comfort, for example, for a certain region. And typically, if somebody comes with a design, with some city design, and asks for such a simulation, you use CFD, and that's a very good simulation method, but it really takes a lot. It's a comprehensive method and takes a lot of long time that you get any results. For example, for a small neighborhood, you need a couple of days that you get the first results. And that is good if you have some final design or near to final design, but if you would like to evaluate different design options and optimize that, you need a result very soon. And there we used AI, for example, to not typically put in any real data, real world data. So we simulated with CFD millions of different variations of how could arrangements of buildings look like, and try to predict with AI what is the wind comfort by the given design. And the result was that we now can calculate the same result with a little bit lower accuracy, because it's a trade-off, in a couple of seconds. And that really changed completely the way of thinking, how we can go into co-creative process, because it was the first time I can go into the discussion with different stakeholders, customers. They do real-time changes of the design, and I immediately receive a result or some idea how climate, local microclimate will look like. And that is also some startup we initiated, so it's Infrared City at the moment. And that idea of using AI for rapid assessment, we name it, we also would like to transfer to mobility topics, to energy topics, to have a holistic approach via our City Intelligence Lab. That is some digital twin lab where you can play around, and then you not only get the results for the climate, but you also get the results, what is the accessibility, how good is, for example, the energy supply potential in that region. And so you can come to a discussion, and at the end, hopefully you find the 5 best solution spaces, and then you can go in more detailed analysis of that.
Thank you. From accessibility to scalability, because when Uber, let's say, was interviewed about their international expansion, obviously they started in the United States, Latin America, Asia, Europe. And one, let's say, point that Uber always brought up that, let's say, that sticked with me was, they said scaling in the United States is absolutely no problem. So once you have figured out, let's say, Seattle and San Francisco, you can take the next 50 largest cities and you're ready to roll. So you don't have to adapt anymore. In Europe, they said it's a completely different game. Basically, every country and sometimes even municipality, you had to treat as a separate project because there were just so many things which are not the same. Yeah, I see lots of nodding heads. That is good. Because what I would like to know actually from the 3 of you, what is your experience when it comes to scalability, rolling out to different markets and so on? How much is actually usable? and or reusable, and how much you have to tailor make for the specific municipality or city? So let's start with Necture.
Yeah. Let's call it like this: the CPO utilities market is complicated. There we discovered different arrangements, like a utility being owned by the community itself, by some companies in between, companies being split out, and so on. So for the CPO market segment, yes, this is. Treating every city like its own project. Yeah, that's true.
And how is this, let's say, if you compare your rollout in the United States versus Europe? So is this also true that every city is a new project within the United States? So let's say, did you have the same experience as Uber, or was it different?
I think this CPO market is quite a chaos market currently. But for the US, it's more simple. It's more private owned, and so you know how the entity that you approach looks like internally from an organizational point of view. Oh, hello. Yeah.
Good. How is this in let's say waste treatment?
Scalability in waste treatment is quite difficult because we have a lot of different countries. They are in different stages of their waste management skills. So we have, for example, countries in Europe, they are doing landfill as their main treatment. We have countries like Austria, Germany, they really try to recycle as much as they can. So we have many different levels of interest, levels of technology we deal with. So scalability in Europe is quite complicated. And internationally it's the same. For example, the go-to treatment for waste in the US is landfill. So there's not a big interest in recycling. So the solutions we develop, they maybe want to have in 20 years or not. Or they stick to landfilling because they have a lot of free space, which is not a resource we have in Europe.
Thank you. Yeah, for you there are too many topics, so I just wonder if you could provide two examples, one where scalability works and one where you say, no, there are just so many preconditions that need to be met, it's basically impossible to transfer this from A to B without reinventing the wheel.
Yeah, thanks for asking that question, because it was exactly the point I would like to mention. Of course, you have some regional differences in scaling up and some different circumstances, but it really depends on the application itself. So if you have an application which is very much dependent on their own data, for example, and at the same time independent from local regulations, then it's very easy to scale up. That example I've given with infrared and the climate modeling, that is something you have some rough design from buildings, and you have some frame conditions there, wind direction, wind speed, and you can everywhere on the world can calculate that wind comfort. That works very good for scaling up that application. In other examples, for example, going more in the direction the construction, and if you have a look in regulations and building codes, for example, you have even in Austria, you have so many different building codes, and it's always hard work to find the right frame to put your design into that. And that is where also AI will give us some benefit in the future, because what we are doing, for example, is to overcome that issue that you always have to read all the building codes and have to fill in all the parameters according to the building codes. We try to use large language models to put in the building codes and automatically retrieve the frame conditions for making, for example, parametric design, so that I can say, okay, I would like to have this region, I would like to have set new neighborhood, for example, and please give me some variations of designs. Then automatically you retrieve the documents on that side. It goes through AI, you retrieve relevant information, and so you immediately can work with a setting which is not vision, so which is really from the point of view of regulation implementable.
That's funny because there's a company based in Vienna called Atlas.design. They do this for video games. So, you know, they don't need to have the proper structural simulation and so on, but you can prompt, for example, let's make a suburb in the UK from Manchester in the 1960s, and their customer are companies like the bus simulator and so on. So you can really play in it.
There are also lots of more if talking about AI and also the potential for the future. Also on the side, we are always talking about digital twins and data, but at the end, it's very important that you have some inclusive design. It's also a regulation in European Union that you need to be stick with equity and inclusion, and that means also bringing into the process people which typically do not have access to such digital twins and expert tools. And in this case, for example, we also use speech models, for example, to talk with the digital model and saying, okay, I need to put that building a little bit on the left, on the right, make some changes in the height, but also using it for paper cuts, for example, to recognizing some interaction with the physical model, because architectures are used to get in touch with some physical things, and they are not used to do all this stuff on digital world. And that also enables for the future really cool ways to work together and to also bring people in some process. And that's not only for urban technology, I would assume, bring people in the process who typically are not able to be in there.
Mm. Zooming out a little bit, because you mentioned this now a couple of times with data and digital twins. So if you, let's say, move back 10 years and think about Industry 4.0. So Industry 4.0, the expectation was always that you will use lots of IT, you collect data, you analyze it, you have less faults, you have higher quality, more uptime, and so on and so on and so on. Around the same time were also the final negotiations for 5G. So, and there the big expectation was that cities will be a combination of, let's say, classical IoT, like LoRaWAN, plus 5G. If I think now what's happening nowadays, the question is where should the data come from? Because many cities actually did not walk the IoT route as it was expected 10 years ago. Some of them, let's say, utilize satellite data. Others, like the city of Vienna, they use so-called mobile capturing campaigns. Think of it like cars like Google Street View that make panoramic images and use a LiDAR scanner to get point cloud data. Where do you think, and this is addressed to all three of you, what will be the database in the future to build technologies on top of it, like SAP is for logistics optimizations in the private industries?
I think one data source could be available telemetry data from vehicles, and public available, not just manufacturer available.
And are there, let's say, initiatives within the industry to make open standards here or something similar?
Perhaps in 5 years.
Okay. Because, for example, Volkswagen is trying to do this. They bought a Swedish company called Neurodynamics, and they sell the data in an anonymized way. So basically, yeah, you could, but of course it only works with Volkswagen vehicles so far, and that is in Germany and the DACH region, that's obviously enough, but let's say in Southern Europe and so on, it would not produce enough data.
And I think additionally there, some regulations are needed to set an acceptable price to acquire such data if, for example, Volkswagen collects this data. Yeah.
How is this in let's say, in your area of expertise? Because here again, if you asked 5 years ago, most of the cities, they would have told you we put IoT sensors in the trash cans, and once they're full enough, let's say, we make a signal that they need to be picked up and so on.
So in logistics, that happened. So they are smart bins, they have a sensor, and if they are full, they are planned to, or behind that is a model. We don't have it in every bin, but in some bins that are markers. For example, if in this region there is some event and most of the bins that are tracked with a sensor are getting full, there is a lorry coming. But in waste management, excluding logistics, we have no real good data at all. For example, for sorting, if we try to train a model to do some sorting, for example, plastics, we look open source, we look on the internet, we don't find a data set that we can use. We always have to do our own data acquisition, and this takes a lot of time. And sometimes the data is acquisitioned by 3 different teams on 3 different universities, companies, and other research organizations, because there's a lack of open source accessible data. And I think that's hindering the development of good AIs in the waste sector quite heavily.
No, this is the perfect entry point about OGD. This means open government data, because the example I brought before from the city of Vienna and the capturing campaigns, the city started to make this data available as so-called open government data. This means any type of research institution could, let's say, have a look at it and build something on top of it, as well as private institutions when they want to optimize a route or, let's say, go check the facades of buildings and think of construction companies and so on. The big question in your side, do you see this OGD movement picking up steam, so that this is, let's say, really becoming a thing Europe-wide or worldwide? Or are these rather those cities that are already far ahead with their own strategies, that they now make even more things that most of the other cities won't be able to follow? Or are we now are we in the early stages of a standard to emerge?
So I really appreciate that initiative. It was very slow at the beginning, so but at the moment I think there's a really also great database, ODG in Vienna, and I do see that Vienna is a forefront runner in that with that respect, but also recognizing European cities there is coming more and more. The big question is not only having some data, open data and free available. I'll work a lot with scientists, and so I would never exclude any data source. But the question is, the problem is a lot of data are collected by private parties at the end, and we have some regulations, but there is, for example, for innovation, we need, or the scientists and researchers need a good access to that data. And at the moment, data is gold for each company. Yeah, I'm back again. Yeah, sorry. Data is back for data is gold for each company, and they want to have their own business model on that, and that's a good idea, and I support that. But it should be in the state when we launch products. It's very important that companies earn the money on the data, but it could be there's a need for more regulations or more forcing also private parties to provide data. Free for doing innovation and supporting economic development in Austria.
Mm-hmm. Yeah, in the mapping space, there are, let's say, certain type of companies which are doing this, but of course not with the, let's say, with the noble goal of sharing the data, but rather, let's say, building up a monopoly, because they have the reusage agreement and can therefore offer so cheap to the municipalities. And they take it, obviously, but then these companies have the monopoly for capturing, so to speak. Time for the closing statement. We're already below 2 minutes. So what should be the closing statement now? I would be interested, from all the urban tech use cases you've seen around the world, which one was so far the most surprising or special one for you? Preferably not from your own company or institution, because that would be, a little bit patting yourself on the shoulder.
So for us, we saw on a travel to a conference a system where you had to put your waste, the thing you want to throw away, on a table. There was a camera and a large model behind it, and it detected what it was, when it was, who produced it, and where you have to put it in which bin. The bin then lit up and you could throw it in there. So it was a sorting assistant of some type, and we saw it on an airport. It was quite something.
That's cool. That would be cool in Japan, because in Japan you have 17 or 20 different recycling categories. So
yes, and they're all different all over the world. For example, we throw plastics in the yellow bin. Somewhere else you throw their metals. So it would be quite nice to have something like this.
I think from my point of view, it's not domain specific, but everybody is experiencing that. I think that the most accelerating market was the image processing market at the end for AI applications. So it's impressive with generative AI what you can do now and how you can act. And there are a lot of vendors in that section.
Some dynamic pricing ideas with bidirectional chargers.
This is like battery alternative use and so on of automotive. Yeah. I'm sure we will talk about this one in 10 years as well.
Yeah.
Yeah. Now this is a very long dream of the, let's say, of the power grids or of the utilities, but so far the car makers are a little bit resilient to opening up the batteries for bidirectional charging. Great. Good, without producing even more delays. Yeah, Ina, hello, I see you. So thanks a lot for the panel. Thanks for the attention. And we directly continue with the next session. But that's all I'm saying, because I no longer will take over Ina's part. So thanks a lot. Thanks to you.